Yeah, we'll get rolling. You guys ready? Everybody get logged in, okay? Good. Okay. Welcome back. Session 6. EMS system training. Today we're going to talk about chilled water, start our major equipment series, right? So there's going to be 3 meetings in this series. We'll talk about the chiller plant, and we'll start talking about major equipment and how everything operates, right? So today we're going to start with just the chilled water section of things. I have just a few quick slides to go through. I'll switch it. Oh yeah. There it goes. There it is. Got it. Okay, perfect. So general stuff, video recordings in session, back here in the back of the room, and then we're recording the screen for you as well. We posted these 4 plus last session, plus the paging system and the pneumatic tube, quick in-service stuff, all up on that YouTube channel for you. So Josh, you can share those links as you see fit. The P2 one that went up there is that short little like Becky in-service, which will be great for the Mercy folks. So I'll go ahead and share that one with them. And if they want to show any of the nurses how to do that, it's like a quick 3-minute, here's what you do that we did. Brian, you were there for that one. So I'll share that one with you as well. The sign-in sheet is here going around. Sorry. And then I will hand out here the evaluations here in a second for the end of the session. So, 90 minutes today. Follow-up items real quick from last session we'll go over, and then we'll get into the chilled water system. Really 3 major pieces here, right? So we're going to go kind of overall, what are those components and how does the chilled water system operate? And then we'll dive into a deeper dive on each piece of the equipment, look at the controls for it, see what points we're getting and how we're controlling them, and then the big sequence of operations and the modes. We'll talk there about plant loading, free cooling, and the different modes of operation it's capable of, a little question and answer, and the evaluations. So, follow-ups from last session. I just threw them all on one slide. So, air changes per hour, that's in progress. We've got to get some of these room volumes so we can calculate the air changes, which we'll get over to Corey, and you can pop them in there. Thermostat quantity locations, we sent those over this afternoon, so those guys will be working on getting those updated on the floor plan so the thermostats actually show where they're located, so that we've done the audit and all that information has gone over. Emergency department room update, we sent those over Friday with the new room numbers, so that's another thing we're working on getting the graphics updated. These things are done, the VAV tags are on all the ceiling grid, the floor plans are all linked with the VAV documentation, so when you're working on those floor plans you can click on them and see where the actual VAV is located. Sequence of operations are uploaded to each of the critical areas that we looked at a couple times ago. And then the automated reports are all generating. Got to get a couple of the air changes calculated correctly, and that'll be behind us. Alarm status, we'll pull that up here first and just kind of look at overall. We just want to keep everybody apprised of where we are, right? We know that we're troubleshooting some stuff. We know we're still kind of dialing in the building, but we want to look every week or every session about, hey, where are we today? Where were we last time? Where are we headed? And how are we making progress on clearing out the alarms, getting the building totally under control? Anything else I forgot? Pretty quick, wasn't much from last session to follow up on. Pretty simple with the floor cooler units, fan cooler units, 38 heat panels. We got to get the cracked units added to the floor plan graphics. Did we get that done, Corey? Do you know? Not yet. Okay, so I'll add that one to the list as well. Make sure we follow up on that and get it done. Today's learning objective, pretty simple, right? Understand the chiller plant operation and its components. So that's really the majority of what we'll be covering today. So pretty simple, one focused little thing we want to get to today. And now Corey, I'll drive for you and then just switch it over. You can just switch? Yeah, as long as. Yeah.
Go ahead and go to the alarms button on the top right. Try here. So we'll see this. This is the entire system alarms. So still quite a few alarms coming in. That's what I'll spend probably the rest of this week working on, is seeing what's nuisance and trying to get those to be valid alarms for you. So now that we've got emails going through, I noticed all weekend long in the ED, VAV 113 was alarming about every hour. back off. So I fixed that for you yesterday, and I'll just start doing the same thing through your entire building. Go through alarms, see what's causing the alarm, take care of it. Questions? You don't want 24,000 alarms in a week? Get them cleared up. Okay, so let's take a look at the chill water system under the plan. So there's several layers to the chill water system. The way I set it up and broke it out for you. Go ahead and expand that chill water system. Okay. So this is all the equipment that belongs to the chill water system. We've got managers for both the chillers, for the pumps, for the tower, and the tower pumps. And then we have individual programs that look at the chillers, 1, 2, and 3, the towers, 1, 2, and 3, preheat exchange, or the heat exchanger for free cooling. And then these down here at the bottom with the different symbol, these represent the integration. So those are the drives for those pumps. Chill water pump, tower pumps, cooling tower. Condensing water pumps, chill water pumps. Okay. So this top graphic, I tried to give you a way to look at the entire plant in one view. Okay, so you can see what pieces of equipment are running, which tower, which chiller, which pumps, and how many you have staged up. So it's just an overview. There is some detail to these graphics, but not a lot of detail. You don't see your pump speeds. You just see the status and if I'm calling for it to run or if the system's calling for it to run. So we're calling for tower pump 2 to run. It's running, it's got a status. Any questions about this graphic? All right, I created some hyperlinks. If you notice, as Joe's moving around, you'll keep seeing a finger pointing. So this section here takes you to the tower manager. Anywhere you click in this section, you're going to get popped over to the tower manager. Chill water manager. So it takes you to different subsystems, so to speak. All right. So let's go ahead and go to the chiller manager. Chiller manager is what initiates the whole system to run. So your chillers run all the time, but staging is developed by the load that the building's seeing. So how many tons of cooling are we running? Right now I've got it set at 500 tons and we'll stage up another chiller. So if the load on the building gets above 500 tons, you're going to stage up. And that's this section here. So here's our chiller staging. So chiller 1, anything from 0 to 500 tons, chiller 1 runs. Chiller 2 is going to stage up at 500 tons, and it's going to stage down 60 tons below that. So when we get to 440 tons, then that chiller will stage back off. And then I have some minimum run times in there. So once I stage it on, I'm going to run for half an hour. And when I shut it off, I'm going to run for 20 minutes. Just below here is what our current tonnage in the building is. So right now we're running at 401 tons. Okay. All right. The system's design was engineered to run at a lead lag with 1 standby. So we should never be running more than 2 chillers at a time. So one's in lead, the lag chiller comes on at 500 tons. Then when we rotate, we'll switch that up. And the rotation is this section here. So want you, it can be a little confusing at first, but all of these systems run the same. So the chiller number, 1, 2, and 3, those are your chiller numbers. And then these are the order they run in. These are the 3 rotations that it can go through. So right now I'm in rotation 3. Chiller 2 is the first one to run. Chiller 3 is the second one to run. And chiller 1 would be the last one. If we had a failure, chiller 1 would come on. So we just rotate through these 3 different rotations. So whenever we change next time, we'll roll over. Chiller 1 will be the lead. Chiller 2 would be the lag. Chiller 3 would be the redundant. We'll rotate again. Now chiller 3 is the lead. 1 is the lag. 2 is the redundant. Does that make sense how it's rotating? These are not the chiller numbers. These are the order of sequence that they run. And behind that, we've got some startup delays and delay off. So when we rotate, how do we bring the chiller up? So we're going to, startup is going to be a 30-second delay. When I go to shut down, if I go from one stage to another, we've got a 30-second, a 1-minute delay. Sorry, 1-minute delay to stage down. Down here below is a manual selection, so you can force these chillers into any one of those sequences that you want to run. And the highest selected takes precedence. So if I select 1 and then turn on 3, this will be the sequence that I run in. These are manual overrides for you to use if you need to force it into a different rotation. Now, if you want to force a unit on, I don't have that on the graphic. I don't have a way to force it on. You could put it in maintenance from here, or you can put it into rotation. So maintenance will lock out a chiller. Here's where I locked out. Sorry, I didn't see it at first. This is where if I wanted to lock chiller on right now, I could turn it on just by clicking that button. That's going to start chiller 1. All right. Any questions?
Corey, is chiller 2 locked on right now?
Chiller 2 is locked on right now, yes. Chiller 3 is in maintenance. So when we stage up, we're going to stage up to chiller 1. All right, rotation methods. Go ahead and just click that drop down there. So we have 5 different rotation methods that you can run on. Right now I've got it set to manual rotation. I've got to click it or accept a rotation. But you can choose to rotate daily, weekly, monthly, or based on the runtime of your primary chiller. So go ahead and select weekly. Get an OK or accept for me. This graphic will change here in just a second. So rotation time is the time of day that this rotation will occur. It's a 24-hour clock. So 1 p.m. on day 3 of the week. Monday's 1, so Wednesday. We leave it in this configuration. Tomorrow at 1 o'clock, it'll rotate to the next sequence. So it'll rotate from 3 over to 1. Start running in that order. Same thing with daily. Daily's gonna rotate every day, but it's still gonna rotate at a given time in the day. 1 o'clock, whatever you set in the system. Monthly, you choose the day of the month to rotate it, and the time of the day to rotate it. And that lets you know if you want to do it in the middle of the night or in the middle of the day, whenever you have the staff to make sure that they can watch that. So it just gives you a time so that you can sit down and say, okay, if we get rotated, everything's up and running, everything's good. So go ahead and put it back to manual form.
So clearly, I mean, obviously in this rotation sequence, chiller 1 would start before chiller 3 would go off, right? Is there, I mean, if there's only demand for one chiller?
Correct. Yep, and that's this little section right here.
I don't know if I missed that, but.
Yeah, so that's this portion of startup delay and the delay off. So we've got a startup delay and a delay off. And I've got a lot of timing built into the sequence to take care of that. I usually like to do my plant rotations and stagger them. So say if I'm gonna do it at 1 o'clock in the afternoon, I'll do my chillers first, do my chill water pumps at 10 after 1, do my towers at 20 after 1. And I like to stagger them and let them go through so that I don't just switch everything at once. Because if you do have a failure, then you get a little overwhelmed with what happened.
Yeah.
And you can delay your restarts. So I like to do it staggered by 5 or 10 minutes, let everything cycle through. Maybe it takes an hour to rotate the whole plant, but.
And did you?
Go ahead and accept that.
Okay. You simply just, to lock one out, you just simply toggle over it, off on.
So the lockout, put it in maintenance up here.
Okay.
To lock it on, you can lock one on here. And to force a rotation, you can choose which rotation to force it into. And you can force a rotation down there.
Got it.
I don't think you were here. Staging is based on load. So once we get over 500 tons, we'll stage up to the second chiller. When we drop back to 440 tons, then we'll stage back down to one chiller. And the system is lead lag with one redundant chiller.
Aren't they 500-ton machines?
Yeah, but I've seen this get up to 540 when I was running it by itself.
Yeah.
So the load I'm basing on the supply and return temp and the flow.
Okay.
So it is a calculated load.
Got it.
It's not from integration. There are some secondary staging. If we get 10 degrees out of set point on our chill water, it will also stage one up. Overview of the graphic, still got the floor plan links, major system links on the left side, the weather data. Got some shortcuts back to the chill water system, the plant area, or the main super west. Okay, each chiller has a differential pressure across each barrel, so we're measuring differential pressure on the chill water and on the condenser water. And that is what we're using to calculate your tonnage, your load, is that pressure, the flow, and the temperatures. Each chiller has its own isolation valves and condenser water, chill water supply, and return temps on both sides of the chiller. Michael talked to you about this handoff auto switch in the top of these graphics. I don't know that they've shown up anywhere else. So the handoff auto switch up at the top, you can force the plant on, you can force the plant off, or you can allow it to run in auto. Auto being that the program is taking care of all the sequencing. All right, documentation on this page. There are 2 documents here. Oh, sorry, here there's only 1. What I put here for you was the sequence that the plant runs under. So you get the mechanical drawings with the sequence for the plant and a drawing. Questions? So let's look at chiller 2. Okay, so as we drill down into the system, what we're doing is just looking specifically at each component. So it's the same information, we're just showing you more of it, I should say. Not the same information. More information about a component. That top right area are the integration points that we're pulling in. So we've got entering water temp, leaving water temp, refrigerant pressure, liquid temp, refrigerant pressure, our refrigerant discharge rate, temperature, and our motor speed. I'll just wait. Yeah. Go ahead and go back to the water chiller system. Back here. Okay. All right, let's go to the chilled water pump manager. All right, same philosophy as the chiller manager. So we have the same rotation information. So rotation, we have a sequence, 1, 2, and 3. What our pump off delays are. And then we can choose again how we want to rotate the chill water pumps. So all of these managers have this same logic behind how they rotate and how they sequence pumps or sequence equipment. So on pumps, if we get above 90%, that's where we stage up another pump. We drop back down below 60%, or sorry, drop below 40%, and that pump will be staged off.
You're getting that reading off the drive.
Getting that reading from the drive. Questions about pumps?
Yeah, you got me.
You got my head
Power
spinning.
manager.
Suzanne.
thing again. I think the documentation on this one, I believe I have. This one I had a layout of the whole plan on there. Probably need to change the name of that. It's the line drawing for the tower program, for the tower system. Let's look at the tower pumps manager. Tower pump manager is the same as chill water pump manager. We get above 90%, we'll stage on another pump. Get below 40%, we'll stage it back off. 30%, I guess, is what it actually is.
What's controlling the fans? Did you already cover that?
Nope, we can go over the fans. So click on tower 1. So I do want to mention, as you see, we're running tower 1 with chiller 1 and tower pump 2. It doesn't matter which pump, which tower. The systems are essentially isolated from one another, so that portion of it doesn't matter. I have to go to the logic because I don't remember what runs the thing. Scroll down for me. All right, so we have a set point that's coming from the chiller manager of 75 degrees to control the fan speed on those towers. And that temperature only changes, you can change the temperature. The system only changes it when we go into free cooling. So when we go into a free cooling mode, that temperature will be reset down to 42 degrees, I believe. And those towers will start cooling off the condenser water so that we can free cool. Okay. We'll go over the free cooling here in a minute.
This gear, lube, level, low,
Yeah, I noticed that.
light flashing need to be checked.
Yeah, it probably does. Saw that the other day.
As I heard, the seal on one of them was leaking.
Was it? Probably that time.
Second, it's probably that one.
Yeah, it's nothing to worry about.
The other one's on
Joe, put Eddie on that.
Yeah.
Got Eddie on point there, Joe?
Oh, yeah. Any questions?
What is that? What are we reading there? Is there an actual point for a level of the gear
Yes.
level? It's not
We have
based on
status.
temperature or something like.
No. We have a status coming back. We're reading an input.
All right. Okay.
All right. Let's go back to chiller manager. Go to the logic for me. I'm gonna have to, I want to explain to you how it goes into free cooling. I don't expect you to go through the logic. Let's pull up to that section right there. But I just want you to know what's going on. So when the outdoor temperature gets below 33 degrees for, I believe it's 20 minutes, we're going to initiate the free cooling sequence. So these set points are all changeable too. These were the initial set points. Sorry, the outdoor gets below 33 degrees for 20 minutes. We're going to transition into that cooling charging mode. We're going to reset the tower temperatures down to 42 degrees. We're going to continue to run the chiller as that temperature comes down. Once that temperature, the tower supplied temperature gets below 49 degrees, then I'm going to open the valves on the free cooling heat exchanger and stop the chiller, send a stop command to the chiller. It will run in that mode until our heat exchanger supplied temperature gets above 50 degrees. 62. When it gets above 62, it'll come out of that mode. Bring the chiller back on. Reset the temperatures back to 75 on the cooling towers. And then start the chiller. So we go into that mode at 33. We take the the condensing water temperature down to 49. Once we get below that set point, then I'm going to stop the chiller, open the valves on the heat exchanger, and run in that mode until we get above 62.
Above 62.
62 on our chill water temperature. And those set points are all manageable by you. That's just the initial set points. You may not be able to keep
That
it.
sound about right? Or that's based upon how we operate?
It's a little high to me.
Seemed a little bit high to me too, but
Oh, like 55?
More like, yeah.
I've seen plants that they could take them that warm. I don't know. 55 seems closer. But we can change all those set points.
So we get that 75 Energy Star rating.
It's right. It may be.
Don't condition the building.
Right. Well, maybe their hope is at 33 degrees, wet bulb outside, we won't get that much treatment, but I haven't seen that here yet.
And where's the data for the outside air light level coming from? Is that
So we do have a weather station, but we are also doing a couple of different things. So we do have a local sensor, and I make changes in the plant based on the local sensors. But the data for targets, I don't know if that's what you're asking, but we do all the reporting with targets. All that data comes from AccuWeather. I think it comes from Tinker Air Force Base. That only resets every hour. And that can get us in trouble in Oklahoma when we don't see the temperature but every hour.
Right.
Because nothing in the system responds instantaneously. Everything takes a little bit of time to get started.
The only thing that's actually being controlled by outside air. Ambient. All right.
So let's look at our integration on one of our pumps. So CHWP1 graphics. So all of your pumps we've integrated to, we've got a set of faults, alarms. Pump has drive fault, overcurrent, main circuit over voltage, motor overload, drive over temp, fuse blown, motor over torque, phase loss, low voltage, under disconnect or common error. The box below the drive itself there gives you the status that the drive's currently running in. This one's running 91.3%. So the signal's what I'm sending it, the speed's what I'm reading back. The speed and the frequency are what I'm reading back from the motor, or from the drive. RPM, current, power consumption, bus voltage, and the AC output voltage. Questions? All that integration should all look exactly the same. Pump 1, 2, and 3 for the tower or the chill water.
The drive image is not interactive, is it?
It is not interactive now. It is interactive on the values, the frequency and the hertz and the percentage. But no, I wish it was.
I didn't want to go clicking on it, but then I get an old man excited over there.
Just don't click it.
Remember, anything you click on, you have to accept it before it's going to happen. So that is one nice thing about the system.
All right.
On chill water system, we look at the documentation under this one. It's kind of to the right down. Okay, this one, I gave you the plant layout and the sequence. So your sequence is in 2 locations, chiller manager and under the chill water system. The plant layout is just the physical layout of all the equipment in that mechanical room. Let's go to, looks like that next one. Chemical treatment. Let's go to refrigerant exhaust. Okay, refrigerant alarms and exhaust systems. We get under the refrigerant alarm, we're going to start that exhaust fan. Open the ventilation into the space. We've got a refrigerant alarm. We've got a chiller 1, chiller 2, and chiller 3 refrigerant leak. I don't think we have a heat exchanger. I'll have to check what that's there. Unless there's one in that area. Okay, let's go back. Chemical treatment is in area 1C, I believe. clean, whenever we get a start command on any of your tower pumps, all we're doing with this system is enabling it and reading a status back. So it's got a circulating pump associated with it and that panel, but all we're doing is starting it. And I've got that's tower clean, and then the chemical system, I've got to get the integration brought up for you. I don't have that complete yet.
Yeah, we don't have differential pressures on this.
I do not. All I have is a status. An enable and a status on that pump. That tower clean is also on this graphic, so it's also down in this section. My link is broken to that area in the building for some reason.
Hey, on that auto blowdown, is that just something that we're not controlling, you're not controlling that?
Not controlling it. That panel controls when it blows down.
That's something, Scott, that you just monitor and adjust as you see fit?
Yeah, it's usually just number 2 hours.
What else do you want to know? That's the general overview of the system.
Talk to us about how you're controlling the bypassing valve of the tower.
Okay,
Tower
bypass. What we're doing on bypass is when the temperature, it's actually on the tower manager. So we're trying to maintain that 75-degree set point on those towers. As we get below that set point, we'll start bypassing the tower and recirculating the water back to the chiller. You're going to see that when we come out of that free cooling mode.
We're trying to get
water warm back up going to those chillers.
So if we look at the logic there, does it show, or the
Go ahead and go to logic.
temperature set points for that bypass valve?
That bypass valve uses the same set point as the tower, minus 5 degrees. So it's going to try and keep it above 50 or above 70.
Great.
That valve should be in this, most of the time that valve should be 100% open. When you come out of free cooling, you're going to see that valve close down and try and warm up that water going back to that chiller. So, make the chiller screw that is.
Is the reason we can't see that logic page just because of the password we have? So we don't even have the option to click on logic.
Yep.
Ain't no logic. You stand up and broke.
Yep, user.
Well, if I had access to the logic, I could fix it.
That's the logic. They have to one Major Scott.
Don't know me, 'cause I don't have logic either.
Just call Josh. Boy, I know you're broken, Philip.
So, and I'll say it again, the chiller manager is what initiates the chill water system. And then each component has its own manager. So the towers have a manager, the pumps have their own manager, but the chiller manager initiates the call. So it's kind of the master controller for all of the systems. There's actually only 2 controllers doing all this, one for the towers and one for the chillers, but all of those signals are managed by the chiller manager.
Scott, you got anything else there?
I guess. Hand buttons are on the drives to get everything running in manual, because when this goes down.
Usually on a holiday.
Low temp chiller on 6 forward, and then we'll look at that, or stick it to the plant area, or what?
Rooftop chiller?
Level 6. Just do this, go find MRI. That drop down. Have you guys used the find function? Drop that right there. Click on find, type MRI. So if you don't want to navigate to something, you can use this find feature to instantly jump to somewhere in the system. And all it's doing is looking at the geographic tree name to direct you there. So if we wanted to look for an exhaust fan 18, you can start typing EF. Here's 19, 11, 18. So it's very sensitive to the context, so it's EF space 18, but I usually just start typing CH until I find what I'm looking for.
Probably in the wrong place. It's under 4th floor.
You're good. That's it. That's what we were looking for.
But it's under the 4th floor tree.
Oh, I see.
And it seems like it should either be under the 2nd floor tree or the rooftop tree.
Yeah.
I think we should move it to the rooftop.
Like it got stuck there because that's where the controller is. That's the
Yeah, so is that chiller for the MRI?
Yeah.
No, that's the low temp for air handler.
okay.
Two. Sorry.
Gotcha.
Yeah. Have you gone over any of the major equipment, any of the air handlers?
Okay, we're gonna start with the plant, then go back to,
Yeah, not yet.
so I didn't get to this.
I think where I'm at too. So yeah, this is low temp coil on air handler 2. We've got two chill water coils on that. We do have a glycol system here. We can send an enable. It's based on pressure. Yeah. As the pressure drops down, we send an enable to the glycol system, turn on a pump. We'll get back a pump status from that. I don't think we're low on pressure good with the logic. I think that thing. Scroll down. don't even turn on the pumps until it's below 25. So we don't actually have a like low glycol. I think that alarm is showing wrong. I'll have to fix it for you. Or that status is showing incorrect. So the glycol system, when we get below 25 psi, that's when we enable that system. We get back up to 30, it'll shut back off. We've got 2 pumps, pump 4 and 5 that run the system. The rotation manager that's there to the right looks just like the rotation manager we saw for the plant. It's the same method.
Only 2 circuits on this, Scott? 2?
When we're enabling that chiller, we get a status back, have a set point of 38 degrees on it.
Well, I don't understand, help me understand what the glycol pressure is about. I don't know when what gets below.
When the pressure, so there is we're actually reading the pipe pressure. When the system pressure, that chill water pipe system gets below 30, and we fill the system back up to 30.
Why would it do that? It's closed loop.
I don't know.
Okay. Scott, you know? I just want to make sure.
Well,
I
it
understand.
should, once you got it filled up and everything's good, you shouldn't have been.
Guess because this one has no
Unless you had
major
a leak
water.
or something. Right?
Yeah, if you had a leak or blowout strainer or something,
Okay.
I mean, it shouldn't vary that far.
And then the other thing that caught my eye is the differential pressure on the chill water supply and return, around 22 psi. Does that seem high?
I'll have to look into that. I'm not sure.
The other DPs were 2 and 3 pounds, I thought.
The plant building supply is running at 27 psi.
Is it? Okay.
Yeah. The chillers are running around 5 psi
Okay.
across the chill water barrel.
Yeah, that's where I see it.
Yeah. Now I have chiller 1 logged. We're gonna get our technicians down there on chiller 1 and 3 because my sensors are bouncing on them. I can't figure out why my readings they'll go from -1 to 4. So I don't know if I don't know what's going on there. Michael looked at it 2 weeks ago, and we're gonna have to have a technician take a closer look.
So if that differential pressure is going up and coming down, is that just the drive controlling the pump?
It's the drive controlling the pump or the valve that's in that air handler changing position.
Got it.
I know Michael did mention there were a couple of these pumps that he wanted to look at the PID loop that's in that pump and how it's controlling. So that we may be seeing that from the drive.
All right.
I haven't gone through this low temp chiller system yet. It's like right now that chiller says it's failed, but it's not.
The trend looks awful squirrely.
Did get squirrely.
Is that typical?
No. Click on that, hover over that trend for me. Just click on that box. So you know how to open those trends up? See the little square white box up here? You can pop that up larger. Because the small trends that I display don't show you what you're actually seeing. So the yellow line on top, chill water supply temp, chill water return temp, and the set point. I don't know why it did that.
What is it?
So it jumped 7 degrees. Actually, it wasn't even quite 7.
Or somebody was up there cleaning the pools.
34 to, what's the yellow
I
line?
think they did that last week.
And the time of day is what's bizarre, 4 o'clock this morning.
about a 6-degree swing. You can turn off the blue one, click on, yeah.
So the load, is that percentage
That load is tons.
tonnage?
Yeah. Can we look at logic for a minute and see what that load is calculated on?
If you look back on June 14th, it did the same thing at 3 a.m.
Scroll down.
2 days ago?
Doing the same thing on the 13th, exact same time. Same thing on the 12th. Exact same time. Yep.
Interesting.
In
Has
programming.
something to do with occupied, unoccupied status, maybe?
Or in programming, maybe.
Everything's occupied right now. You can hit page up. Go back further.
I described it, Joe, and scroll back.
Let's not go too far. Let's not go too far.
That's useful.
Yeah, it is cycling right there, isn't it?
Mm-hmm. Right here. It's pretty neat.
So it's a good place that I can build since we're only having to control one coil here, we can actually create a trend that looks at both of those pieces of equipment at once. Go back and look at what the air handler is doing at that same time on that low temp deck. I'll create that trend for you so we can see what's actually happening. Because the load's dropping out.
It's right there in the middle of the night too, isn't it?
3 a.m. to 6 a.m. Or 9 a.m. Just drop it in.
Yeah. Cool. It's all right, we can talk, we should, anything else on the chiller plant, guys? Or anything else you want to start diving into? Or talk about what, where we go next? So we covered, floor coil, fan coil, crack units, gradient panels last time, then skipped over to do kind of the chiller plant. We can continue with the boiler portion of the plant next time, and then move into, we can go back and do air handlers, or we can continue forward with exhaust systems and the miscellaneous areas.
I think we drop back with the HUs,
Okay.
do boilers. Surely boilers won't take 90 minutes.
No, well, the boilers, I mean, they have their own boiler management system, right, the vendor, so that'll mostly be covered in United's boiler training. These guys really just pick up a few points and enable.
We're just turning it on
Yeah.
and sending a set point. And it's an outside air reset too.
Right.
Maybe we do a brief overview on that and jump straight into AHUs on Thursday.
Okay. Cool. And we'll just take the AHUs in order, and how far we get, we'll maybe take 2 sessions, or we'll maybe do them all in one. You guys kind of are most familiar with air handlers, it seems like, so probably not a ton to cover there, with the exception of those first 2, right? AHU 2 that's got the cool deck, and AHU 1A, 1B that's a little more complicated than the others, but those other ones will be pretty quick, pretty standard air handlers.
Yeah.
Okay.
Go back to the chiller manager. One last time, there's one thing I do want to make sure.
It's pouring at my house right now. The sky just dropped out. Crazy.
It's great.
Drop for you to the chiller.
Don't have to run the sprinkler.
One thing I do want to make sure everybody knows how to
Just got my day
do.
yesterday. It's laying on the ground.
We need to get the system to take a chiller offline, put it in the maintenance mode. If you need to lock the chiller on for some reason, you can lock it on here. So I just want to make sure you know how to take it out of rotation and how you can force it on if you do have an emergency.
Lock it on down here and lock it out up yonder. Very much.
Yep, yep. So maintenance means it's locked out.
Locked
It's gonna
out.
take it out of rotation. Yep.
Come down here and lock it on. Now, you got 2 running there, let's say I lock on number 1,
I've
the
got-
2 stay running?
Yes, yes.
Okay.
And what it'll actually do, if we lock on one right now, it's gonna start a pump, it's gonna open up, it's gonna start a tower pump. Chill water pump is based on pressure in the building side, but it will start a tower pump and open a tower. So we can only run 1 pump on your towers. We're blowing apart pipe when I try to run 2 during that. What I originally tried to do when I opened my second chiller was just start another pump and run water through it, because I didn't need another tower on. But I blew the pipe apart on the spray water. So now I actually start another tower pump, run that water till I'm ready to shut down that other chiller. So that may be the only odd thing to see when you go through rotations. That chiller rotates, you're gonna actually see the tower down.
Yeah, that's kind of cool. I mean, usually you got a tower.
Usually I can run the water through 1 tower.
That won't take long before that other one's got to kick on because the water tanks will get it.
Yeah. So I don't have a long delay. I'm only proving the second one for about a minute right now. I may decide, they start pretty reliably, but I may decide that it's 5 minutes or something. Shut that other chiller down. We can adjust that. First thing I want to get fixed is these pressures right
It's a little
here, so
slow.
that I'm going to start rotating. As soon as those are fixed, I'll start rotating the chiller.
So that's the chiller plant in 60 minutes or less, right? So as you guys start with this stuff, right, we're still meeting for 5 more weeks. So please, like each session we'll stop and say, hey, what'd you run into and what questions do you have that we can help answer? So use that opportunity to ask these guys questions, or if something's not quite working right, we'll go troubleshoot it for you. So we'll dig into the chiller number 4. That was one of the items that we had to pick up. And then we'll add the crack units to the floor plans, which is the follow-up item from last time. What else? Next time we'll dive into the boiler plant, which will be real quick. And then we're working on getting United set up for next week also to do the actual boiler training. And then we'll go ahead and start doing air handlers. That'll go pretty quick. I mean, it's up to you guys, right? The level of detail that you want or the questions that you have, but we're happy to run through those as quick or as slowly as you need us to. So we'll just start running through them and tag on the next ones we don't get through to the next session. Sound like a plan? Cool. 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 Is it getting easier? That you're getting more familiar with the system? you guys use this at all during the week? I mean, the idea, I guess, is to kind of set it and forget it until it all shoots craps and Scott has to go put everything in manual, but it's okay. I mean, hopefully it's becoming a little more familiar to you, right? Because it'll take some time, for
You
sure.
call on Sunday, pull it up and look at it.
That's the idea,
Yeah.
yeah. So let us know if there's any adjustments you'd like to make in the meantime, and otherwise we'll see you guys Thursday this same time.
All right.
Okay, thank you guys.